An introduction to adding and subtracting radicals. First thing that you want to remember when you're adding and subtracting radicals is that oftentimes your radical is treated like a quasi-variable. What I mean by quasi-variable is obviously a radical is a number, but it'll oftentimes take on characteristics of a variable. Example, if you recall back to just regular addition and subtraction of like terms, if you have 3x plus 5x, because the variables are the same, you go to the coefficients and you simply add 3 plus 5, keeping x as your label. So this would be 8x. Another example of this might be if you have 5 tiger, take away 2 tiger. Because the tigers are the same, when you have 5 tiger take away 2 tiger, you are left with 3 tiger. Your label does not change. In class you've heard me say often, when adding and subtracting, create no new animals. It would be the same case when you're dealing with radicals. So an idea. If you had 3 rad 2 minus 5 rad 2 plus 7 rad 2, notice that all the radicals are the same. So you would be able to add and subtract the coefficients, keeping the label of rad 2. Example, 3 take away 5 is negative 2 radical 2. Negative 2 radical 2 plus 7 radical 2, negative 2 plus 7 would be 5 radical 2. And you see that the radical was just a label, it didn't change. And we'll continue on with this concept. So we'll do another idea. In this idea I have 5 radical 3 minus 2 radical 7. Because the radicals have different values under them, that's as different as having an x and a y. So if I had 5x minus 2y, I would never think of adding or subtracting those. 5x minus 2y, I know I would stop. So here's an example, albeit very rare, where the original problem is actually the answer. In other words, I can't simplify that. So I get 5 rad 3 minus 2 rad 7. Because the radicals were different, I could not add or subtract them. And so I just stayed right where I was at. Let's do a third idea before we move on to some examples. In this problem I had 4 rad 8 minus 3 rad 50. On the surface it would look like those radicals are different, so it would be no different than the last idea. I would stop. However, when you inspect the radicals a little further, notice that the radical 8 could be broken down as 2 times 4. And 4 is a square, so I could have 2 squared 4 under this radical. In a similar way, the 50 could be broken down as 2 times 25, where 25 is 5 squared. So you notice inside my radical I write the 8 as 2 squared 2, because I need that 2 to get out of the radical. It has to match the index. And for the 50 I called it 5 squared 2, so it has a 2 to get out of the radical. Which at that point it would allow these numbers to come out and be joined with the numbers that are already outside. They come out through multiplication. So when I look at this first part, it'd be 2 times 4 is 8, radical 2. When I look at this second part, the 5 comes out, it becomes minus 15, radical 2. Now this is very much like our first idea. The radicals are like. So I would be permitted to add or subtract those coefficients and come up with an answer. And my simplified answer would be a negative 7 rad 2. Next I'd like to do a bunch of examples explaining how to do the addition and subtraction of radicals. This was just an introduction where we're looking at the variables and the radicals are very much the same. Oftentimes you'll treat a radical like a variable even though it's a number. And so you have to break those radicals all the way down until you get them so that they can no longer be broken down and they're treated like that variable or that label. So like in this last idea, 8 rad 2 minus 15 rad 2 guaranteed that I was having a rad 2 as part of my answer because it was nothing more than a label. And so there's our introduction to adding and subtracting radicals.